Hello students, so we are going to continue our discussion on derivatives. So the last question I had asked you one question. What is the derivative of fx is equal to x cube, right? And the correct answer is f dash x will be equal to 3x square. Using the first principle, we derive the value of derivative of x cube as 3x square. So if you pay careful attention, or in our first example, we had fx as x and its derivative f dash x was equal to 1. Our second example we saw fx equal to x square and f dash x is equal to 2x, correct? And the third example, this is number 3 example, where fx is x cube and f dash x is 3x square. So if you identify the pattern here, right, fx is x, f dash x is 1, fx is x square, f dash x is 2x, fx is x cube, f dash x is 3x square, right? If you identify the pattern over here, we come across that if fx happens to be x to the power n, that means this index, it is 3, it is 2 and here it was 1, right? If the index happens to be n, then you see in this case the third example this index comes as a coefficient and there is a one decrement of the value of the index, that means x cube was 3x square. Similarly x square was 2x to the power 1, that means fx x to the power n or f dash x will be equal to n x to the power n minus 1. And in fact, when we are going to discuss the formula, finding derivative using formula, this is the very first formula that we are going to write down. Because using first principle was a very primitive, you can say, very initial way to find out the derivative of a function, using first principle. After that, when we know the formula, then we use the formula to find out the derivative of a function. So this will write down as a first formula. Alright. But now we'll continue with our discussion of derivative with first principle. So here is the example number 4. As I told in the previous video that we are going to deal with now binomial, trinomial and so on, because in the first 3 questions we dealt with only the monomial, the polynomial with only one term. So here it is the trinomial we have, right? So beginning is same only, we know that f dash x is equal to limit of h tends to 0 f of x plus h minus fx upon h. Okay, this beginning is same. After that, it is a time to insert the values for fx plus h and fx value is as it is. Okay, so what we are going to do, it is limit of h tending to 0 if fx equal to x square plus 5x plus 1, that means f of x plus h will be x plus h whole square plus 5 of x plus h plus 1. Okay, so this is the value for f of x plus h. Okay, minus fx ka value is this only, x square plus 5x plus 1. Alright, the entire expression is divided by h. So after writing this individually, we have to apply the value. I am writing on the top now. This x plus h whole square, a plus b whole square formula. So it will be x square plus 2xh plus h square. This is a plus b whole square formula, plus 5x plus 5h plus 1, okay, minus this entire thing will be minus now, x square minus 5x minus 1. The whole thing is divided by h. Now look at the expression in the numerator carefully. We see that this x square will get cancelled. This 5x will get cancelled. And this 1 and 1 will get cancelled. Okay. So what is left out? Let us have a look at it. Limit of h tends to 0. This x square gone. 2xh will remain. Plus h square will remain. Plus 5h will remain. And rest of the things will get cancelled, divided by h. After this step, what we are going to do, we'll divide the numerator by h. So h will divide 2hx, it will make 2x plus h plus 5 only. Okay. Now we have to go back to our previous topic. When x is tending to 0, this entire expression will tend to, this quantity will tend to 0, so only 2x plus 5 will be remaining. Okay. So therefore what we can conclude? Therefore in our question, ddx of x square plus 5x plus 1, this is equal to 2x plus 5. Okay. And if we think along the line of applying formula also, you can see derivative of x square is 2x, derivative of 5x will be 5 only, and derivative of a constant is 0. So next question I will show you how come derivative of a constant is 0. So example 5, we have taken a constant function fx equal to k. Like in chapter 2, we had discussed constant function means whatever you give in input as an input for x, the output is always a constant, right? So here you can see fx equal to k, right? So if we try to find out f dash x, as usual we write down, we know that f dash x is equal to limit of h tending to 0, f of x plus h minus fx upon h. So now what is the function that we are dealing with? Is a constant function. So therefore, irrespective of the input, the output is always same, that is k. And in case of k, you can write any real number. K belong to here are any real number. You can write down 2, 3, 4, 5, whatever it is. Alright. So that means if x plus h is the input, output is k. Here the output is also k. So divided by h. Correct. So k plus k minus k, we have limit of h tends to 0, 0 by h. And 0 by h, it is 0 only, right? Limit of the 0 is 0. So therefore, derivative of a constant function is 0. In the next question, now we are switching from algebraic function to logarithmic function. Okay? fx equal to log x, where x must be greater than equal to 0. Alright? If x is less than 0, the logarithm does not exist. So it has to be always positive. So let us see what will happen. So beginning is same. We have written, we know that, then the first principle formula, and then using the functional value. If fx equal to log of x, then f of x plus h should be log of x plus h minus log x divided by h. Now we have to apply the property of logarithm. So I have written it on the top. कि log of m minus log of n. That means the property that we are using is log of m minus log of n is equal to log of m by n, right? So using this property of logarithm, I have written x plus h by x. All right. After this, some algebraic technique we have to adopt here. Limit of h tends to 0. You see, this expression I can write down as log of 1 plus h by x divided by h. I hope you understand what I have done. X divided by x is 1, h divided by x is remaining as this only. So we know that the logarithmic formula of limit, the formula goes like this: limit of x tends to 0, log of 1 plus x upon x equal to 1. This is the formula of logarithm in case of limit. But here condition is that this x, this x, this x, if these three x are identical, then only this value becomes 1. Okay. But here what we see? What do we see here? Ki this is h by x, this is h, this is h. These two are fine, but this is h by x. Alright. This is our h by x. We can make change in this one, we cannot make a change over here. So what we are going to do? This h I will write down h by x and I multiply one x also. Then this balance is maintained here. X cancel, h by x. Now you see, this limit limit is effective for x tends to 0. So this x will act as a constant. Okay, it will come out. So 1 by x and the remaining part is limit of x tends to 0 and log of 1 plus h by x divided by h by x. Okay. Now let us look at the formula. This x, these two are identical now. One part is achieved. These two are identical. But we know that if h is tending to 0, definitely h by x will also tend to 0 only. Right? Common sense. Because this x, it will act as a constant here, this x, because limit is effective on h. So now, whatever is the necessity that these three terms should be identical, so this is also achieved. H by x, h by x, h by x. Therefore, this entire value, this will become 1. So write down 1 by x into 1. So definitely the answer is 1 by x. Therefore, the ddx of log x is equal to 1 by x. Example 7, we switch over to exponential function now. Fx equal to a to the power x. So beginning is same. We know that. Again the first principle formula. So if fx equal to a to the power x, f of x plus h should be a to the power x plus h minus a to the power x. Now what we see in this one, if we apply the law of exponent, then this quantity can be written as a to the power x into a to the power h minus a to the power x divided by h. Right? We know that a to the power m plus n is a to the power m into a to the power n. So we have applied law of exponent. Next, we see that a to the power x can be taken common in the numerator and the remaining part is a to the power h minus 1 divided by h. Okay, and as limit h is tending to 0, this a to the power x will be acting as a constant here. So we'll write down a to the power x limit of h tending to 0 a to the power x minus 1 upon h. and you will be happy to see that this is the standard limit. What is its answer? Its answer is log a. So this is, we can write down a to the power x log of a. Therefore, we can write down ddx of a to the power x is equal to a to the power x log a. From this only, we can have one more example. You can say, if we write example number 8 as fx equal to e to the power x. That means in the same example, this a is replaced by e now, the exponential constant. So that means this implies your f dash x will be equal to e to the power x log e, correct? And what is the value of log e? Log e ka value 1. So this answer is e to the power x. So ddx of e to the power x is e to the power x. And this is the only function whose derivative is the same as it is. E to the power x, e to the power x. And this function is known as actually stubborn function. That means some people are there who cannot be changed. Whatever you do, they will always be as it is. Right? So this is called stubbornness. Okay. So this function e to the power x is known as stubborn function, because whether you differentiate it, integrate it, it will remain e to the power x only. Class 12 mein integration will come, but class 11 mein differentiation. Even if you differentiate it, answer is e to the power x. You integrate it, answer is e to the power x. Although constant function, differentiation is 0, and integration mein one x will come. But only this is the only function whose integration differentiation is same. So far in these two videos we have discussed derivative of algebraic function and the exponential function and logarithmic function. In the next video we will see derivative of trigonometric function. Thank you.